Okay, so we've been talking about functions and their inverses and one-to-one, right? So if it's a function, every input has what?
One output.
Exactly one output, right? If this function is one-to-one, what can you say about the inputs and outputs?
Each input has a unique output.
Right, and each output comes from a unique input, right? There's nothing, basically there's nothing duplicated on the X or the Y side, right? If it's one-to-one. And for a function, we had a test that told us if something was a function, if you have the graph of it, what's that test?
A horizontal test.
Not the vertical line for function, right? And then for one-to-one, what was the test?
The horizontal.
Horizontal line test shows it's one-to-one. But don't forget, if a function is one-to-one, that means its inverse is also a function, okay? But, so now in this lesson, we're going to focus on the inverses of linear functions, right? So a linear equation, the highest exponent on the variable is what in a linear equation? There's one on your screen right now, like y equals 2x minus 4. What's the highest exponent?
The -4.
That's not an exponent.
One.
What's the exponent on that x?
The 2.
That's the coefficient. What's the exponent? It's x to the what power?
1.
1, right? It's not written, it's a 1. So a linear equation has as its highest exponent a 1. And a quadratic would have an exponent of what? X to the... Okay, I'll just tell you. Second, x squared, right? Would be
So 2.
Yeah, okay. All right, so let's look at these here. Exercise 1 on the grid below, the linear function y equals 2x minus 4 is graphed along with the line y equals x. So if we look over here, so here is y equals 2x minus 4, and you all should know what the line y equals x looks like, right? Every single point on it, the x and y coordinates are equal, okay? So how can we quickly tell if y equals 2x minus 4 is 1-to-1? What are we going to do? Do I have to write the whole thing? Yeah. Horizontal line test, right? And if we do that test, is that a function 1-to-1?
Yes.
Yes, it is, okay? And also, what could we say about its inverse, since it's 1-to-1?
As inverse, it also has to be 1-to-1.
Well, not necessarily. The inverse is definitely a function.
It's a function.
Right. So like if you were to graph its inverse, it would pass the vertical line test, okay? So now they want us to graph the inverse of y equals 2x minus 4. Let's not calculate the inverse of the equation. All we're going to do is do what to the x and y coordinates?
Swap them.
Switch them out, right? So let's take a couple of them here, right? So I don't know, let's take this point here, 2, 0. The inverse of that would be what coordinates?
0, 2.
0, 2, right? So right there would be the inverse, okay? Let's pick another point. How about 1, -2? What would be the inverse of that?
-2, 1.
-2, 1, right? So we have 2, 0, and -2, 1, right? And, well, 2 points to find a line, right? So we could go ahead and graph that line, couldn't we? I'm going to use a straight edge here, I think. Graph that, arrow on it. Let's see. Color. We'll do a different color. We'll do it in, oh gosh, I don't know. How about in green? Okay. So if we connect these, wait, did we get that? Look, I didn't plot that one right. Scratch that. Hang on, guys. Whoopsie daisy. Let's erase that. You got me all flustered here. So -2, 1. There's the point right there. Okay. So that's -2, 1. That's why we do math and pencil, guys. All right, so let me draw a line there. Make that one the green line. And if we connect these, kind of like that, extend that out a little bit. Okay, you don't have to be using a straight edge yourself, but I just want to kind of keep this nice and neat. Okay, so that would be the inverse of our original function, right? So in other words, what did we do? What geometric transformation happened here? Do you remember from geometry? It's something to do with the line y equals x. What did we actually do to graph that?
We mirrored that.
Okay, what's our big kid math word for mirror?
Reflect.
Reflection.
Function of the
In
y equals x.
the line y, so y equals x is the mirror, right? So then that makes sense that you're going to just switch the x and y if that's the line you're reflecting in, right? Okay, let's go down to part C. What can be said about the graphs of y equals 2x minus 4, the original, and its inverse? Well, we just said it, didn't we? I got ahead of myself, right? So they are reflections of each other. First of all, we got that. They are reflections of each other. Okay. And are they both one-to-one functions if we did the horizontal line test?
Yes.
So both are one-to-one. Okay. All right. Let's go down here to part D. They want us to now find the inverse of our original equation in this form. Okay. Y equals x plus b over a. So let's write down our original equation. Y equals 2x minus 4. And what's the first thing we do to find the inverse? Well, we got to do something first. With the x's.
Which line?
There we go. So we end up with x equals 2y minus 4, right? And now I can add 4 to both sides, right? X plus 4 equals 2y. And what do we do finally? To solve this for y?
Divided by 2.
So we'd end up both sides plus 4 divided by 2 equals y, right? And so if we put that in inverse function notation, we'd have this. F inverse of x equals x plus 4 over 2. See how we have it in this format here? Okay. Now they want us to find that inverse in y equals mx plus b form here over in part E. How are we going to do that? So there won't be any fraction over here. Why don't we just divide each of these terms by 2? So it would be x over 2, right? What's another way to write x over 2? Dividing by 2 is the same as multiplying. Well, dividing by 2 is the same as multiplying by what?
Multiplying by one
a half, right? So wouldn't this be 1/2 x plus what?
1/2 plus 2.
And now we are in mx plus b form. What's the y-intercept of this equation?
As next to 1x.
The y-intercept is 2, right? And the
Yeah.
slope is 1/2. Let's go up and take a look. Let's look at our inverse up here. Do you see where it crosses the y-axis up here? That's at 2, right? And what's the slope? Up 1 over 2, 1/2. Okay? All right. So I'm going to go down here to exercise 2. and we're going to do the switch X and Y thing, okay? So they want us to find the inverse of Y equals 5X minus 20. All right, so let's go ahead and do that. The first thing we're going to do is what? What's the first thing we're going to do?
Switch the X and Y.
Okay, go ahead and do that. So X equals 5Y minus 20. All right, I want you all to go ahead and solve that for Y and work out what the answer is there. Give you a minute.
Yes.
What is
It's
it?
number 4.
Choice 4. Okay, I hope you got that. Let me run through it here for those who might not have gotten it. So we can add 20 to both sides, which would leave us with this. All right, and then we divide both sides by 5. Right? But none of the choices look quite like this, right? So they all look like they're mx plus b form, right? So that would be y equals x over 5 plus 20 over 5 when we split that fraction up. And that would
That means it
be
should be Y equals 1/5 X plus
plus
4.
4, right? So choice 4. Dividing by 5 is the same as multiplying by 1/5. Okay? Let's go on to the next one. So again, we're going to find the inverse of this function. So let's go ahead and switch x and y here. Y was 2/3 x plus 8. So we'd have x equals 2/3 y plus 8. Okay? I'm going to give you all a second to work through that one. What am I going to multiply both sides here by?
Swords.
Right, and use parentheses, right? Anybody get it yet?
Yes, it's number 1.
Choice. Well, what's the inverse, though?
Oh, the inverse. It's Y equals 5 swords X plus 15.
So 9 divided by 3 is 3, times 5 is 15. Right? I use function notation now. Because now to find the y-intercept, what am I putting in for all the x's?
Zero.
So our f inverse of 0 at 0 is 15. Okay? Again, some of you guys, your algebraic work's a little bit rough. Please look and see how I'm doing it here. This is what yours should look like. Notice I have full sentences, everything with equal signs, right? Okay, so choice 1. All right, let's move down to example 5. Which linear function would not have an inverse that's also a function? Okay. Well, we have to take a look at each of these, right? Let's just make a quick graph of each of these, right? Because to find out if the inverse is a function, we need to take the graph of each and apply the horizontal line test, right? So what would the graph of y equals x look like?
Just
It's that, isn't it?
Yeah.
Okay. What about 2y equals x, right? Well, this would be y equals 1/2 x, isn't it? I divide both sides by 2. So that would be, right, a lot like the other one, wouldn't it? Would the inverse of both of those also be a function? If we
Yes.
get the horizontal line test, okay. Let's take the graph of y equals 2. What axis does it cut through?
It only cuts through the y-axis.
And in this case, it cuts through it at 2.
That means it does not pass the horizontal line test.
Right. It's a horizontal line, right? So another horizontal line will intersect it infinitely many times, right? So its inverse would not be a function. All right. This one here is another linear equation, right? So all, you could say all but one type of linear equation is one-to-one or has an inverse that's a function. And the only type of linear equation that would not have an inverse that's a function would be that horizontal line like that. Does that make sense? Okay. Okay. Well, that wraps that lesson. Okay. Any questions on finding the inverse of a linear equation? Switch x and y, solve for y. And you know the y-intercept is found where x equals what?
X equals 0.
And the x-intercept, if you ever asked, is found where y equals what?
0.
Okay? In all inverses, when you graph them, are a reflection in what line?
The y equals x line.
Y equals x. Okay, does anyone have any questions?